is a video on reviewing graphing polar coordinates and switching between polar coordinates and rectangular coordinates, both from point to point and also from equations. So with an emphasis on equations. So, and this worksheet is something that I provided my class with initially. So this is for my class, this video or this worksheet is found in the 0-week module. So, and I'm guessing that many of you have already done it before class started. But anyway, I'm just going to pick a couple of points here and go over how to graph them again. I'm going to do C and F. So remember that the first coordinate is the radius or the distance from the origin, and the second coordinate is the angle that you've turned from the positive x-axis. So it's really kind of a directional. The second coordinate tells you which way you're facing, and the first coordinate tells you how far to move, so to speak. So this says that you're going to turn pi radians. So if I'm already, right now I'm facing this way, after I get done turning, I would be facing that way, because that's that's pi radians. And then the 8 tells me to go out 8. So that'd be, since I'm facing in the negative x direction, I'm going to just walk out the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, and that would be the location that this is describing. This 8, comma pi. So that would be C. So then if I want to find F, that would be negative 2 pi over 3. So remember, 2 pi over 3 means negative means go in the clockwise direction. So negative 2 pi over 3 would end up putting you in this direction here. I don't know if you can see that yellow very well. Maybe I'll trace it with red to go with the yellow. Oh yeah, you can see that a lot better. Okay. So negative 2 pi over 3 tells you to be facing in that direction. And then this says my radius is negative 4, which means I'm going to move 4, but I can move it in the opposite direction that I'm facing. So since I'm facing this direction, that means I'm going to go out this way. 1, 2, 3, 4. So that would be my F point. Okay, so let's cruise on down to this next one. Find the rectangular coordinates for each of the following polar coordinates. So in this case, the best thing to do, I think, is to draw a picture. I want red. Let's pick a different color here, like blue. So if I draw a quick picture of this, I know that it roughly looks like that, because that angle right there is 5 pi over 6. So the main thing what we're doing is looking for a right triangle. So in this case, you can see a right triangle that sits like this, where that would be pi over 6, because that's what's left here. And this is the x, sorry, I did that last time. This is the y coordinate, and this distance right here would be the x coordinate, because you can see those things showing up right there and there. So once I establish that, then I know, because of my trig knowledge, I know that, let's see, sine of pi over 6 is equal to, oh, and also remember in the drawing that because the radius is 4, that means this is 4, because that's 4, right? So sine of pi over 6 would be opposite, which is y, over hypotenuse, which is 4, which means 4 times sine of pi over 6 is equal to y. And of course, we all know that sine of pi over 6 is 1/2. So that means that this would be 2. So, in my search for rectangular coordinates, I know the y coordinate is 2. And I could do a similar thing to find the x coordinate, because we know that cosine of pi over 6 is equal to x over 4, because it would be adjacent over hypotenuse, which means that 4 times cosine of pi over 6 is equal to x, and cosine of pi over 6 is rad 3 over 2. So that would reduce to 2 rad 3. Now, in this case, we have to be careful because when you go back and look at the drawing, notice that we know by looking at the drawing that the x-coordinate is negative because it's going to the left. The y-coordinate is positive because it's going up, but we know that the x-coordinate has to be negative. So I'm going to put a negative there and then write my 2 rad 3 in there. Okay, so if we're going to go the other way, we're given rectangular coordinates and we want to switch back to polar coordinates. That would be like, for example, number 4 here. So the first thing that you might have noticed is that it gives you this little range here, because when you think about polar coordinates, because the nature of spinning around the circle, we can spin around the circle an infinite number of times and end up at the same place if we want to. So in other words, so that means that there's going to be infinite different ways to express a certain location using polar coordinates, because I could spin around the circle 30 times or once and still be facing in the same direction. So that's why they give you this extra little piece of information, so that when we answer this, we'll all have the same answer. Okay, so we're looking for an angle to be between 0 and 2 pi. So don't spin any more. So you can't spin around the circle more than once. Okay, so once again, I'm going to start by drawing a picture. So when I draw a picture, I know that I'm over 1, 2, 3, and up down 1, 2, 3. So there's a point right there. So that's what I'm trying to find. I'm trying to describe how to get to that location using polar coordinates, which means I've got to figure out how long that is. That would be my r. And I need to find this angle here. Why do I need to find that angle? Because this angle would be a negative angle, and that wouldn't be inside my little range here, right? Okay, so to find the angle, what I'm going to do is I'm going to take, I know that, well, let's find this angle right here, actually. So we know that this is 3, and that's negative 3. So that means that tangent of alpha, we'll call this little guy alpha. Thank you. Tangent of alpha has to be equal to, and we'll forget about the negative for a minute, 3 over 3, which of course is 1. So we know that tangent of alpha has to be equal to 1. When is tangent equal to 1? That would be at pi over 4. So we know that little angle is pi over 4, which means the angle that I'm looking for, that goes all the way around like this, would have to be pi over 4 short of a complete circle. So that means that my theta that I'm actually looking for, that's the theta up here, my theta would be equal to 7 pi over 4. Because 8 pi over 4 would be one complete trip around the circle. So then, now we just got to find the radius. So the radius we know because of the Pythagorean theorem, right? We know that 9 plus 9 should be equal to r squared. Of course, that means that 18 is equal to r squared. So that means that my r is going to be equal to the square root of 18, which would be equal to 3 times the square root of 2. So, what is the rectangular or polar coordinates that they're looking for? That would be 3 times the square root of 2, comma, 7 pi over 4. Now again, just to make everyone clear on this, there's a lot of different ways I could describe the same point. I could have said 3 rad 2, comma, negative pi over 4. That would have got me to the same location. Or I could have gone negative 3 rad 2, comma, 3 pi over 4. That would get me to the same location. Let me just make sure you're clear on that. Let me use red to make that clear. So if we were to graph, what this would look like is I would turn 3 pi over 4. So we're saying that's 3 pi over 4 there. So I'm facing in that direction, but then I go 3 rad 2 out this way because it's a negative 3 rad 2. And of course there's a bunch more we could do, but that's good for now. Okay, so hopefully you guys are feeling pretty good about the graphing polar coordinates and switching back and forth between points. Now another step up is dealing with these equations. So change the polar the following polar equations to rectangular equations. So I'm going to do a few of these. So the main idea is we just keep in mind all the time that r squared is equal to x squared plus y squared, and that tangent of theta is equal to y over x, and essentially x is equal to r cosine theta, and y is equal to r sine theta. Those are kind of the three equations that we established by just looking at that little, and if you forget them, you can always just draw the picture again. We know that x and y are here and here, and we know that r and theta are there and there. And so just by looking at that picture, you could be reminded of all these equations, okay? So when I look at r equals theta, r equals 8, that just means the radius is 8. Now these are equations now, right? So I'm trying to come up with an equation that will describe the same graph, but I'm using x and y variables instead of r and theta. Now, so notice what this is saying. We'll think about this intuitively, then just go the formulaic way. So this is saying that r is equal to 8 all the time, no matter what theta is. So you could try to get a, if you just wanted to picture that, well, that just means that I'm always 8 away from the origin, so that would be out here somewhere. And no matter where I turn, I just stay 8 away from the origin. So that, you can see, is just a circle, right? Because that would be 8, and that would be 8, and that would be 8, and that would be 8. No matter which direction I'm facing, I'm 8 away from the origin, okay? So that's the picture that we get from that, r equals 8. So how are we going to come up with the equation? Well, if we know our equation of circles, we know that if you have a circle that's centered at 0, 0, and a radius of 8, that would just be x squared plus y squared is equal to radius squared, which would be 64, right? So that would be the equation. Now, if you don't know the equation of circle, it's not something that's sitting on the top of your head. What we're going to do is go up to this little thing here, and we say, we know, well, we could use any of them, but we choose this one because there's no theta involved here, so it doesn't make sense to bring in a theta. And so that rolls out these other three. So it makes sense for me to say, well, this since r is 8, we could replace that with 8, and this would be 8 squared is equal to x squared plus y squared. And notice we get the same thing as that. So I just took that r is 8 and plugged the 8 right into there. Okay? Okay, let's do a couple more here. R cosine theta equals 6. Well, we know that r of cosine theta is x, isn't it? That tells us that right there. So I could just replace that with x, and we get the equation x equals 6. Which is just a horizontal line, isn't it? I mean, I'm sorry, a vertical line. Okay? Let's see if we can get a little bit harder one. Oh, this one's interesting. So r equals negative 5 cosecant theta. Excuse me. So my first move here would probably be that y equals negative 5 over sine theta, because cosecant is the same thing as 1 over sine, right? So then that makes me think that if I multiply both sides by sine theta, I get r sine theta is equal to negative 5. And we, again, know that r sine theta is just y. So I could replace this with y, and I get y equals negative 5. And that would be an equation in rectangular coordinates. One more. This one's a little bit trickier because we don't have that nice r sine or r cosine. And we can't get, I guess we can get it. But there's a 7 there, which is not r. That doesn't help us. So we're trying to get, again, we're trying to use these equations up here. So here's a little trick you can use. Remember, you could do the same thing to both sides of the equation, and as long as you do the same thing, it remains an equivalent equation. So what I'm going to do is multiply both sides of these by r, and that would give me r squared is equal to 7r sine theta. And notice what that did is it gives me a couple things I can use quite nicely. We know that r squared is x squared plus y squared, and we know that r sine theta is the same thing as y. So I'm going to replace r squared with x squared plus y squared, and leave the 7 alone because that's just a number, and then replace r sine theta with y. And there we have an equation. So notice I did have an equation with just r and theta in it, and now I have the same equation because we did everything we did was true and right. Now we have a same equation, but it's in rectangular coordinate system instead of polar coordinate system. So again, the point is on all of these, if you graph the given equation on a coordinate plane, and then graph the blue equation that I came up with on the same plane, they would match up exactly. They'd be the same graph. That's what we're claiming here. Okay, so here's another section. Now we have rectangular coordinates, and we want to change those to polar. So again, we're using those same relationships. I see x squared plus y squared, and I immediately think r squared is equal to 81. And of course, we could write this even simpler by saying that r is equal to 9. So again, that's not surprising because it's just like before. We know now you know that's a circle because you can recognize that as the equation of a circle with center at 0, 0, and it has a radius of that square rooted, and that's exactly what this says. R is 9 no matter what theta is. Okay, here's another one. Y equals -5. Of course, we can replace y with r sine theta, and voila, we have an equation with just r's and thetas and no x's and y's. Come down here, y squared equals 10x. Okay, so again, I can replace y with r sine theta, but then it'd have to be squared, and then this would be 10 r cosine theta. And you could notice there's r's on both sides, so I could rewrite this as r sine squared theta is equal to 10 cosine theta, because I don't need to leave both r's in there. So just simplifying it a little bit, and that would be an equation with theta and r in it and no x's and y's. If we do one more here, so I'm going to replace x with r cosine theta, and replace y with r, so I'll just square that, sine theta, and that's equal to 7. So not much we can do with that, so that would just be I changed it from an equation involving x's and y's to an equation involving r's and thetas. All right, well, hopefully that was helpful, and the next video will be we'll be working on taking polar coordinates and graphing them.